Hello team. Today's challenge is the knight moves challenge, where we are given a position like d5 and we're asked to find out how many positions how many positions the knight could actually move to. If you've never played chess, the knight moves in a bit of an L shape, so it would go up to from d5 up to d7 and across to e7, or backwards to c7. Or it could go across to f5 and up to f6, right? So we'd have f6 or f4 and all the way around. Technically, there's only 8 positions that the knight could move. So we don't need to worry about things like d6 or e6 or d7. We just need to worry about those 8 positions. And that's really important, okay? So over to the code right here. I've already taken the liberty of building the grid. The one difference here is that you'll see that I put A1 in the top left corner, whereas they have it in the bottom left corner, right? Because this is kind of chess notation. I don't know if it's 100% accurate. I don't play professional chess, so but I do believe that they start in the bottom left corner for chess notation, whereas we today are going to start in the top left because it makes the math easier. Okay, that's the whole thing. It makes the math easier, so we can totally do that. Everything else in here is exactly the same. So row 1 is all the ones, row 2, row 3, all the way down, not a problem, okay? Our possible moves, again, there's only 8. So we only need to look at 8. That's really important because that saves us a lot of steps, right? And a lot of complication in terms of checking different things and checking to make sure we're actually allowed to move to that spot. Let's just hard code the 8 values and get on with it, okay? Down here, the question becomes, we have this position, and this position is a letter value, okay? But what we really need is 2 indexes, right? The index for the row and the index for the item inside of that row, right? And how do we get there? Now we could loop through, right? Loop through each row and then loop through each item in that row to find our thing, return it that way. Very heavy-handed. It gets the job done, but it's not fast. And all that looping takes time. You could try it with find index or index of, depending on where you are. Doesn't change the fact that you have to loop. But if you look at this, we're actually already given that position, right? The D4, right? That D is the 4th letter in the alphabet, right? The 4th letter. It's the 4th position, which means that if we take whatever this value is for D and subtract 1, we get the index. And if we take whatever this value is and subtract 1, we get the index for the column, or for the row, technically. The numbers, these are backwards, so the numbers are the rows and the letters are the columns, okay? So we can absolutely do that, right? I'm going to type in A1 just as an example, like this, and we are going to do it. So right here, row, column, and we destructure that. Excellent. Now, the row is a little bit special, okay? So we'll come back to that in a second. But the column is very easy. So we take that position, excellent, and we go car code at 0. Now, what is 0? Well, it's the first position in this string. So we're grabbing that A. We don't need to split it or do anything fancy. We just go and grab the first letter, the A, and it gives us a Unicode number. A is not the first number in Unicode. In fact, it is the 65th number in Unicode because you have both lowercase and uppercase. Uppercase letters start at 65. Kind of a curiosity. So in order to get A as a 0-based index, we have to subtract 65, okay? We could take this and bring it up here, okay, and go car code at, 1, right? And again, numbers don't start at 0 in the Unicode table. It's, I think it starts with a bunch of punctuation. I don't remember. But if we want this, we need to go 49, okay? The observant of you, and hopefully that's everyone, will have noticed that this is a 1, which is the first column, or the first row, sorry, which means that we really only need to subtract 1. So if we really wanted to, we could skip this step and go position at lowercase a at 1 and just -1. And that works too. Both these are very fast. I think carcode at is a little bit faster, and that's because remember that 1 right now is a string, and we have to coerce it to a number. So that coercion, changing it from a string to a number, takes just a little extra time, slows it down, but still super fast. In fact, taking a quick look, both these are the two examples that we're working through. Both of them are faster than all the other options that I tried, okay? So moving on, we're in it, okay? We have the row, we have the column. Now all we need to do is work with them, okay? And for that, we can roll up a count, okay? And we're going to iterate on possible moves. So right down here, possible moves dot reduce, and the reduce takes an accumulator and a current value, and we do stuff. It starts at 0 because count should be 0 in this case, right? Current is one of these, right? So it's got a pair of values in here. We can destructure that. So we get the row delta and the call delta, okay? And we can work with those. Now, what's the first step of every reduce? Well, return the accumulator. We always have to return the accumulator, especially when there are conditionals inside of here. Otherwise, things will break. We will not get the result we want. We always have to return something. And if we don't have this return statement, it will return undefined, which breaks everything, right? It just breaks everything. So always return the accumulator, and now we can do our if statement, okay? This is where we use board, okay? So we have board, and we take that row, right? And we plus row delta, okay? So row plus row delta is pretty much going to get us there. It's going to get us the row, okay? We don't need to worry about changing the operator or anything like that because 1 plus minus 1 is 0. 1 minus 1 is 0. It's the same thing, okay? We can do the same with the columns. So col plus col d, okay? Excellent. There is a small problem with this, and it is the fact that what happens if row is undefined? Well, if row is undefined, trying to find something inside of it is going to break our app, okay? It's going to crash the whole thing. So we need a way to test if row plus row d actually exists. And we do that. We could go back here and do a little test, but the easier way is just some optional chaining like this, which gets it done. So optional chaining works like this. If this is undefined, it stops and just returns undefined. If it has something, then it goes to the next step, right? So we're in good shape there. And what are we doing here? Well, we are returning accumulator plus 1, okay? At this point, we need to use that count before I try to run it. And now it works, okay? Like a few different steps here, but we have it, okay? The first was setting up our data. How are we going to test against this? Could we have built something out of this and worked with that? Yeah, maybe. I mean, we could have probably tested to see if the C existed, right? We can subtract from C and add to get E and do some stuff. There's probably some sort of algorithm in here that will get this done, but this is quick and painless, okay? And a chessboard is always going to be the same, right? It's been an 8x8 grid for probably thousands of years at this point, okay? The knight can only move in 8 positions unless you're playing special rules and not professionally, because the knight can only move in 8 positions. So let's test against that, okay? We don't need to go fancy. From there, we get the position. We didn't have to loop through any of this. We used the data we were given and transformed it into the data we needed, which is really, really nice, really slick. I like this a lot. And it saves all that looping, because that looping does take time. It is a performance hit, okay? Unfortunately, we did need at least one loop in terms of the reduce, but We test to see if there's a value there. If there is, we add 1, spit it out, return it, done. Okay. And it works pretty well. This is not the only solution. Another idea that I had after I had coded this and got ready to record this video was the idea of going backwards. So what if instead you started with a count of 8 and you said, is it up against the edge of a screen? Okay, subtract these, right? Is it up against this side of the screen? Subtract this, and then just count what's left, right? So there are other options. There are other ways to come about or come at this problem with different solutions, okay? Which leads to the question, what did you do, right? Like there are plenty of other options, and I would like to see yours. So definitely share those down in the comments, and let's start that conversation. Until then, I will see you tomorrow.